Hello everyone, welcome to my first lesson on sequences and series, and I would like to start this topic by going through the baseline test. Now the baseline test I have in front of me here comprises two questions. Question 1 has two parts, A and B, and question 2 also has two parts, A and B. The total number of marks is 25. Please stop this video if you've gone through this topic already. Go through the questions and try and attempt them. And then you can come back and watch the video after that. So let's start with question 1 then. Question 1, we're required to evaluate A, the sigma notation, of course, the sum of all numbers 3i plus 2 from I equals 1 up to I equals 20. The second one is the sum of all 5 times 3 to the power 2 minus k from k equals 2 up to k equals 21. The number of marks is 3 marks, and that one is 4 marks. And then we can move on to question number 1b. So let's go through question 1a then. So question 1a, we just capture it. Our answers: number 1, A and 1. It says here the sum of all numbers from I equals 1 up to 20 of 3i plus 2. So the first thing you have to do is to write this one in terms of term number 1 plus term number 2 plus term number 3 up to the last term. So we're going to do the following. This is going to be equal to substitute 1 into that place there where there's I, and you're counting obviously from 1 going up to 20. So this will be 3 times 1 plus 2, that's the first term. And then the second term, from 1 you go to 2, it will be 3 times 2 plus 2. Let me use a square bracket here, and then plus. The third term is going to be 3 times 3 plus 2, and then plus. The last term is going to be obviously 3 times 20 plus 2. Remember, the place of I, we put 1, 2, 3 all the way up to 20. Now let's simplify this. So the series then can be written as 3 times 1 is 3 plus 2, that's 5. That's our first term. And then plus our second term is going to be 3 times 2, that's 6 plus 2, that's 8. And then our third term is going to be 3 times 3, that's 9 plus 2, that's 11. And then plus 1, 2, 3 dot dots. And then plus 3 times 20, that is 60 plus 2, that will be 62. Right. So this is what we have. Now at this stage, we're supposed to determine what we call the first term. Obviously, you can see is 5. There it is. And then we're supposed to work out the number of terms, because we have the last term and we'll have the first term there. Number of terms, n, is always the formula upper bound minus lower bound plus 1. Now what is our upper bound here? It's 20. Minus lower bound is 1. So upper bound is the top number there, and the lower bound is the bottom number here. So I equals 1, that will be our lower bound, all the way up to I equals 20, that will be our upper bound. So minus 1 plus 1, and the answer is 20. And then we're going to use the formula, the sum of the first n terms equals n over 2, and then we have to say A plus L, because we know the first term and we know the last term. So therefore, the sum of the first 20 terms, n is 20, will be equal to 20 over 2. What is our first term? Our first term is 5. What is our last term? Our last term is 62. And then we punch this into a calculator. Obviously, that will be 67 plus 10. Remember, 20 over 2 is 10 times 67. It's supposed to be 670. 670. That will be the sum. So this series simplifies to that number there. The question says evaluate, so we have to just work on this and produce that. Right, the 4 marks distribution of the 4 marks. This one has 3 marks, yeah. This is how I would distribute the 3 marks. You'd get a mark for that one there, and you would get, I think that can be seen, you would get a mark for substitution into the formula, and you'd get a mark for the final answer. So that will be 3. Right, let's move to question number 1A2. 1A2 is this one here. We're supposed to evaluate this series from k equals 2 all the way up to 21 of that 5 times 3 to the power 2 minus k. So when you have a power like this, what should come to your mind is that this most likely is a geometric series. So let's just do the same thing we've done in question number 1a 1. So this is 2. We've done 1. Now number 2 is the sum of all 5 times 3 to the power 2 minus k from k equals 2 all the way to 21. Now again, we're going to say, we're counting from 2 this time. We're going to say, put 2 there. So it will be 5 times 3 to the power 2 minus 2 plus, because that's what the sigma notation says, 5 times 3 power. From 2, you're counting, you go to 3. So it will be 2 minus 3 plus 5 times 3 to the power. Remember 2, 3, it must be 4 now. 2 minus 4, and then plus 1, 2, 3, plus the last term is going to be 5 times 3 to the power 2 minus 21. Remember the last value of k is 21. Let's simplify this. So this is going to be equal to 3 to the power 0, obviously is 1 times 5, your first term is 5, plus this one here, remember it's going to be 5 times 3 to the power minus 1. This is going to be plus 5 times 3 to the power minus 2, plus 1, 2, 3, plus our last term. All right, you can see it there, right? Plus our last term is going to be 5 times 3 to the power 2 minus 21. It must be minus 19. 2 minus 21. The answer is minus 19, correct? Or minus 19. That's our last term. Now, obviously, you can see this cannot be arithmetic, because if you subtract this from that, and then this from that, the answer will not be constant. Let's just check this. We are basically saying 5 times 3 to the power minus 1, and then we're subtracting 5. The answer is minus 10 over 3. Let's subtract this just to check. So it will be 5 times 3 to the power minus 2, that term, minus this term here, minus, let me go down, minus 5 times 3 to the power minus 1, times 3 to the power minus 1, and the answer is not the same. Remember, now it's minus 10 over 9. At first it was minus 10 over 3. So this is not arithmetic, and therefore, obviously, we try, if it's geometric, by dividing this by that. The 5's cancel, it will be 3 power minus 1. When you divide this, the 5's cancel. This divided by that, it will be 3 power minus 1. So we know that this is geometric. And therefore, we are going to say our first term is 5, obviously. There it is. That's our first term. And then our common ratio is going to be 5 times 3 to the power minus 1 all over this term here, 5. And the formula is, the answer is actually 1 over 3. 3 power minus 1 is 1 over 3. Obviously, if you want to use the formula for the common ratio, we say R equals Tn all over T over Tn minus 1. That would be the formula for the common ratio. But in this case, I'm not interested in using the formula, just taking the term, dividing by the term. So this term divided by that term, our answer is that. And if you divide these two terms, this into that, you get the same result. All right, so that's our common ratio. Now, what do we need? We need number of terms. So what is the number of terms? Is upper bound, the formula says, minus lower bound plus 1. What is the upper bound? Well, upper bound is 21. Minus lower bound. What's lower bound? Well, it's 2 plus 1. The calculator here, this is going to be 22 minus 2. The answer is 20 again. Purely by coincidence that the number of terms in the first one is the same as number of terms in the second one here. I think we found 20 as well, yes. Now, the sum of a geometric series, remember the common ratio is less than 1. So we're going to say sum of the first n terms is going to be equal to a, open brackets, 1 minus r to the power n all over 1 minus r. So we know our n is 20, therefore sum of the first 20 terms, this will be equal to, what is our first term? 5, open brackets, 1 minus, what's our common ratio? 1 over 3. How many terms do we have? 20 terms, all over 1 minus 1 over 3. substituting the values that we've worked out. Let's use a calculator for that one. So we're going to say in the numerator, we have 5 times 1 minus, and then we have open brackets 1 over 3. We raise that number to the power 20, and then we close that bracket, and then we say 1 minus 1 over 3, like so, right? And then when we press the equal button here, the answer comes out at 7.499999, which can be rounded off to 7.5 basically, right? So this is approximately or to 2 or 1 decimal place, if you want to call it, rounding it off to 1 decimal place, that should be 7.5, right? So that's our solution. The comma that we use in South Africa in high school, it will be that one. At university, obviously, it's a dot. So just take note of that, right? So question number 1 is A is done. Let's move on to question number 1B. Here is question number 1B. Mark distribution for this one. This is how I would distribute the marks for this one, and it has 4 marks. As you can see here, it has 4 marks. There it is. How would I distribute the marks? Well, I would give a mark for that, producing the series. I would give a mark for the common ratio, and I would give a mark for the substitution of the number of terms into the formula, and I would give a mark for the final answer there. So that would be 4. Right, let's look at question number B, number 1B. Number 1B says, consider the following arithmetic series. We have 3 plus 8 plus 13 plus 18 plus plus 498. The first part says, express the series in sigma notation, like this. There's no mention of whether the lower bound should be 1 or not. And if there's no mention of whether the lower bound should be 1 or not, we assume the lower bound is 1. And so we answer this as follows. So what we have is number 1B. We have the series 3 plus 8 plus 13 plus 18 plus 1, 2, 3 of our dots plus 498. The first thing we have to do is to calculate the number of terms. So of course we have to determine the general term first, the nth term formula. So we're going to say our first term is 3, and obviously you can see this is an arithmetic series, and the question has said it, I think, the following arithmetic series. Yes, it says here, consider the following arithmetic series. So we don't have to even test it because we have been told it is arithmetic. So we can work out our common difference. It's going to be 8 minus 3, and the answer is 5. And therefore we can say our general term, t subscript n, the answer is a plus n minus 1 times the common difference. What is our first term? Well, it's 3 plus n minus 1. What is our common difference? 5. Simplifying this, it's going to be 3 plus 5n minus 5, 5n minus 5. This simplifies to 5n minus 2. That will be our nth term expression. So this t subscript n equals this. We're going to need this one. And then after this, we're going to say, therefore, we take this t subscript n, we equate to the last term. And what is the last term? Is 498. So what is this? This is 5n minus 2 equals 498. Let's solve this one. For n, 5n will be equal to, add 2 on both sides. This will be 500. And therefore n will be equal to 100 if you divide both sides by 5. And then we're going to say simply, therefore, 3 plus 8 plus 13 plus 18 plus 1, 2, 3 plus 498, the answer must just be equal to, please take note of that, the answer must just be equal to the sum from, we can choose n equals 1 all the way up to 100 of what? In that place there, we're going to put the general term of 5n minus 2, and then we're done. This is what the question is requiring us to do. Remember, I told you that if the question says nothing about lower bound or upper bound, like in this case, it says nothing about whether we must take our lower bound to be equal to 1. We assume it's 1 because naturally you start counting from 1. So this would be our solution. How are these 4 marks distributed? This is how I would distribute the 4 marks. So the first mark would be determining the nth term formula or expression. The second mark would be equating the nth term formula to the last term. And the third mark would be determining the number of terms. And our number of terms is 100 here according to our calculation. And then the last mark would be assembling all that information together. So that would be 4 marks. Right. Now let's move on to the next one. Now watch the second one here because this was number 1. This was B1. Now let's look at B2. Now B2, they are not silent anymore. They are saying express this series in sigma notation. The lower bound is equal to 3. So it means we must have k equals 3 or n equals 3. And then we will have to determine where we're supposed to end. All right, let's look at B2 then. So we have the same series. Let me use this marker here. Number 2, the series is the same. 3 plus 8 plus 13 plus 18 plus 1, 2, 3 plus 498. If you remember from the first one there, we calculated the number of terms, but assuming this has come on its own, this is how you would approach it. You would say, of course, the first term is 3. Our A equals 3 according to this one here. And then you would work out the number of terms. That would be the first step. So what are we saying? Our common difference is actually 8 minus 3, and the answer is 5. And our last term equals 498. So we would say T subscript n is A plus n minus 1 D, and this should be equal to 498. What is our A? Well, our A is 3 plus, we don't know the number of terms, but we know the common difference is 5. So this is 498. What do we do next? We're going to subtract 3 from both sides. So it will be n minus 1 times 5 is equal to 495. Subtract 3 from 498, you are going to have 495. Divide by 5 both sides, you're going to have n minus 1 is equal to, divide this by 5, it should be into 45, that's 9, that's remainder 4, into 45, that's 9. So that should be 99. Let's just check here. It's 495 divided by 5, the answer is 99, correct, 99. And then take 1 or add 1 on both sides, you're going to find n equals 100. This is what we already determined in part 1. But now the question says the lower bound being equal to 3. Here it is. It says the lower bound is equal to 3. So we are now going to say, we know the formula. The number of terms is upper bound minus lower bound plus 1. The number of terms has been worked out, so that's 100. Upper bound we don't know. They are telling us that lower bound must be 3. So this is what you have. So we have to determine the upper bound. So that's 100 equals upper bound minus 2. Add 2 on both sides. You'll agree with me that upper bound equals 102. So we're going to say from n equals 3 up to 102. So now, so far, we have obtained the lower bound and the upper bound. We need the expression there. We need this expression. Now, how do we determine that expression? Well, this is what we do. Remember, they are saying lower bound being equal to 3. So we are now going to say, let me go to the next page. We're now going to say T subscript n is going to be equal to, what is our common difference? Our common difference is 5. It doesn't matter whether upper bound or lower bound changes, our common difference remains the same. So we're going to rely on that and say the formula says dn plus our constant c. And this changes to 5n plus constant c. So that's the general term. But remember, we need c. And they're telling us that the lower bound is 3. So let's say our T3, that will be 5 times 3 plus c. That should be equal to the first term here, because that's our lower bound. So what do we get? That should be equal to first term. So this is 15 here plus c equals 3, and therefore c equals minus 12 if you subtract from there. And therefore our general term is going to be Tn, put the minus 12 into that place, 5n minus 12. And so we can say now comfortably that we're now rewriting that 3 plus 8 plus 13 plus 18 plus 123 plus 498 must be equal to the sum of all n equals 3. Remember lower bound being equal to 3. And what did we find as our upper bound? Upper bound we found 102. As you can see it here, 102. So it will be all the way up to 102 of what? Of this expression here, which is 5n minus 12. Now, if you are doing grade 12 in South Africa, I would like to challenge you. Evaluate this series here. Compare your answer with what we got in example 1. Compare your answer with this one. Evaluate this series, get the answer down, and evaluate this series, get the answer down. You're going to find the answer to be exactly the same. Remember, here you're starting from 1, you're ending at 100. Here you're starting from 3, you're ending at 102. It's basically, if you've done functions, this is horizontal translation or shifting the function 2 units to the right. Remember, you're starting from 1, and then you're in the first one, we're counting from 1 here. But in the second one, we're counting from 3. So it means we have moved to the right 2 steps, from 1 to 2 and then to 3. I'll talk about that, the functions approach, probably when I start looking at this topic in detail. But here we're just going through this baseline assessment, and therefore this would be our solution for part 2. So let's look at mark distribution then. This one has 5 marks. The first one, the normal one, 4 marks. This one has 5 marks, 1 mark more than the traditional one. So how would you distribute these marks? Well, here is how I would distribute the 5 marks. So this would have 1 mark, obviously. The number of terms would have 1 mark. And the general term here, I would give 2 marks for the general term. You say, why would you give 2 marks? Well, I would give a mark for that approach, and then I would give a mark for the general term. Or if you like this mark here, you can put it here. But I would give 2 marks for this calculation from here up to there. And then finally, this would have 1 mark. So that would be 1, 2, 3, 4, and then 5. This is how I would distribute 5 marks. Like I said, this mark here, you can put it here. It's just fine. But the reason why I put it there is because just remember, this is obtained, and then you just put it back there. So this mark here caters for that. All right, but that mark, it shows that you understand that you can't take 3 as your first term like T1, because they're saying lower bound being equal to 3, which means that should be T3. This should be T102, if you understand what I mean. All right, let's look at question number 2 then. Question 1 completed. Question number 2, here it is. It says here, using your knowledge of series, prove that 0.3 with a dot at on the top there, we understand that this is recurring, is a rational number. By definition, a rational number is a number that can be written in the form of P over Q, where P and Q are integers and Q is not equal to 0. Basically, they're saying, right, express this as a proper fraction. So how do we do that? Using the knowledge of series. So question number 2, we're going to say, question number 2 here, and we're talking about 2a, we're going to say 0. So let me say proof here, because they say prove that that is a rational number. So proof 0, 3 with a dot on top is exactly equal to 0, 3, 3, 3, and then this continues. Now, we understand that you can rewrite this to 0, 3, the first part, and then when you are considering this term here, there must be a 0 there. So be 0, 0.03. If you're considering this term here, there must be 2 zeros there, plus 0, 0.003. Just to check if this is true. By adding these up, it must give you that exactly. But it's recurring, so we're going to say plus 1, 2, 3. So let me just check this. 0.3 plus 0.03 plus 0.003. What does the calculator say? 0.333. Like I told you, the first three terms here, they add up to that. So this is obviously, as you can see, a geometric series. How do I know? Well, this divided by that. 0.03 divided by 0.3, the answer is 1 over 10. Let's divide this by that. 0.003 divided by 0.03, the answer is again 1 over 10. So this is a geometric series, to infinity. To infinity, because the three dots are showing you that you don't stop. It's recurring this. So now we know that our first term, therefore our first term is actually 0.3. There it is, 0.3. Our common ratio, we worked it out. From there, we're going to say 0.03 all over 0.3, and the answer is 1 over 10. And so this is all we need for us to work out the answer. So we're going to say, therefore, we're going to say 0.3 with a dot on top. We can write it as s to infinity. And what is s to infinity? A over 1 minus r. What is a? 0.3. What is r? 1 over 10, like so. Punching this into a calculator, if I may write it in that space there, is going to be, check this out, 0.3 all over 1 minus 1 over 10. The calculator says 1/3. This is exactly equal to 1 over 3. And we all know that 0.333 is actually 1 over 3. Because if you press the equal button here, of course it's 1/3. But if you press the SD button, it gives you 0.333 recurring. There it is. So this is how it would come in an exam for 4 marks. I would want to warn you, if you're doing grade 12 and you're in South Africa, this one comes almost in every exam in the course of the academic year. So please go through this. If you don't understand, give some comments. Give us some comments in the comment box. I may actually want to bring this many examples on this when I start dealing with the topic in detail. How would I distribute the 4 marks? These 4 marks here. I would distribute the 4 marks as follows. For writing that in this form here, I would give a mark for that. And for determining the common ratio, I would give a mark for that. For writing the formula for sum to infinity, okay, so common ratio is this one actually, 1 over 10. That is a mark. And then for substitution in the sum to infinity, 1 mark. So there's 1 mark for the series expansion, knowing that this can be written like that. 1 mark the common ratio, 1 mark for substitution in some formula for sum to infinity, and then 1 mark for the final answer there. So this would be your 4 marks. That's how I'll distribute the 4 marks. Right. Let's look at number B, the last one. So number B here, it says here, consider the following arithmetic sequence. We have 7, 11, 15, 19, all the way up to 403. The question says here, determine the sum of all terms of this sequence that are not divisible by 7. Please take note, when you see this word not, it's a complementary rule that must be applied. So the approach is we add up all the terms. We work out the sum of all terms and then work out sum of all terms that are divisible by 7. And then we subtract. Complementary rule, because you are either divisible by 7 or not divisible by 7. So if we know all those terms that are divisible by 7, we can sum them up and then subtract from the sum of all terms. The difference should be the sum of all terms that are not divisible by 7. That's how we approach it. Because if you go directly to terms that are not divisible by 7, they do not form any sequence that you can work with very easily. All right, so this is how the approach is for question number 2B. Question number 2B, I'm basically saying question 2B, we are saying 7, 11, 15, 19, all the way up to 403. So our task, first task, is to work out the number of terms and find the sum of all the terms. And then we're going to produce a sequence of terms divisible by 7 and find the sum of all those terms, and then we subtract the 2. Complementary rule, remember that. So our first term is 7. Our common difference is 11 minus 7, that term minus that term, or 15 minus 11. The calculator here says, I think that's 4. Yes, correct. Do we know the last term? Yes, 403. We don't know the number of terms, so we're going to say t subscript n. We are told this is arithmetic. It's a plus n minus 1 times d. This should be equal to 403. Do we know the first term? Yes, 7 plus. We don't know number of terms. Do we know the common difference? Yes, 4. The answer is 403. Subtract 7 from both sides. We get n minus 1 times 4. The answer is 403 minus 7. 403 minus 7, and the answer is 396. 396 divided by 4 both sides. You're going to get n minus 1 equals 396 divided by 4. It must be 36. That's 9. Remainder 3. 99 again. So let's check. 396 divided by 4. 99, correct. And then add 1 both sides. You're gonna get n equals 100, right? So we know the number of terms is 100. What are we doing next? To find the sum of all terms. Therefore, the sum of n terms is gonna be n over, remember, 2. We know our first term and we know our last term. So therefore, the sum of the first 100 terms will be equal to 100 all over 2, and then our first term is 7. Our last term is 403. What does it say on the calculator? Well, this is 50 times, and that will be this is actually 410, but let me just be careful here. 403 and close brackets. The answer is 20,500. This means adding up all these numbers from 7 up to 403, following of course the fact that this is an arithmetic sequence, this is what we get. Now let's produce a sequence of terms that are divisible by 7. The first one obviously is 7, and for me to see the sequence, I have to write out a few more terms there. So our next step then, if I may move this one down, yeah, you can see what I'm writing there. Our next step then is gonna be a sequence of terms divisible by 7. So what do we have? We are going to obtain it as follows. We're not saying this sequence is 1. I'm going to write it down here, but we're going to siphon or get it from here. So 7, we have the next one is 11, and then we have 15, and then we have 19. Remember, I'm adding 4 because the common difference is 4. So let's continue adding 4. That will be 23. Add 4, that will be 27. Add 4, that will be 31. Add 4, that will be 35. At least you can see something now. Let me just go through this again. Add 4, 11, add 4, 15. Yes, if we add 4, we get 19. Add 4, 23, 27, 31, 35. Then we continue adding 4, 39. Add 4, it's going to be 43. Add 4, it's going to be 47. Add 4, it's going to be 51. Add 4, it's going to be 55. Add 4, it's going to be 59. Add 4, it's going to be 63. And then we can continue. Now, I want you to notice something here. Notice these numbers. Terms divisible by 7. There is 1, there is another, and there is another. So the question is, does this form an arithmetic sequence? Let's check. So we're going to say 35 minus 7. 35 minus 7. The answer is 28. What about 63 minus 35? 63 minus 35. 28 again. All right. So it forms an arithmetic sequence. But the task we have now is to determine the last term. Remember, we're supposed to stop at 403. So could this be the last term of all terms divisible by 7? Let's check. we divide this by 7 and see if the answer is a whole number. So it's 403 divided by 7. The answer is not a whole number, which means this one is a term of this sequence, but it is not a term of all same terms divisible by 7. So what do? We want to check the term before this. Remember, when you're moving forward, you add the common difference, and when moving backwards, you subtract the common difference. So we're going to say now 403 minus 4, because our common difference is 4. The answer is 399. Is this number divisible by 7? Yes, it is. So our last term is going to be, let me multiply by 7 here. Our last term is going to be 399. So we are going to say, therefore, sequence of terms divisible by 7. Let me remove this part here. It doesn't look very nice. This part here doesn't look very nice. All right, that's better. The sequence of terms divisible by 7 is, the first term is 7, then the second term is 35, the third term is 63, and the last term is, remember, we said the last term is 399. How did we get this? By subtracting the common difference from 403, which is the last term of the given sequence. That number 403 is the last term of the given sequence, and this term here is not divisible by 7. So we check the term before, and if we found that the term before this was also not divisible by 7, we would continue subtracting the common difference and dividing to see. That's a manual approach. There is a better approach. You'll see it when I start looking at this topic in detail. You'll see it. All right. So our last term is 399. Yeah, 399. So now we have to work out the sum of all these terms. Now, how do we do that? Well, we need to work out the number of terms first. So we know that our first term is 7. Our common difference is 35 minus 7. We said 28. Our last term is 399. And therefore, we're going to say T subscript n equals A plus n minus 1 times the common difference. This should be 399. What is our first term? 7 plus, we don't know the number of terms. What's our common difference? 28, remember? Equals 399. Subtract 7 from both sides. So 399 minus 7, the answer is 392. So we are now saying n minus 1 times 28 equals 392. Now we must divide by 28 both sides, as follows. So here we go. We're now on page 11. Yeah, I think you can see what I'm writing there. So much paper here. We just put this in order. All right, here we go. That's fine. So now we're going to say this implies that n minus 1 will be equal to divide by 28 both sides. 392 divided by 28, my calculator says 14. So this is 14, and therefore n must be equal to 15 when you add 1 on both sides. So we're going to say, we know that the formula says for sum over 2, and then we have the first term plus last term. But how about the sum of 15 terms? That would be 15 all over 2. What's our first term? What are we doing? We're adding all terms divisible by 7. We're adding all these terms. Our first term is 7, our last term is 399. So we're going to say 7 plus 399. And our answer is, remember, these are terms divided by 7. Our answer is going to be 15 all over 2. And then we say, open brackets, 7 plus 399, close brackets. My calculator says 3045. 3045. So this is 3045. So here is where our last step is. The complementary rule says sum of all terms is equal to sum of terms divisible by 7 plus sum of terms not divisible by 7. Now they want us to work out this one. Do we know this? Yes. Sum of all terms, we calculated it. Here it is. Sum of all terms, there it is. 20,500. Do we know sum of all terms divisible by 7? Yes, 3045. So we're going to say this is 20. Let me write it down. This is 20,500 is equal to this number here is actually that number there, 3045. And then we're going to say sum of all terms, terms not div by 7. You can clearly see that we have to just simply subtract. So therefore, sum of terms not div by 7 will be equal to 2500 minus 3045. What is our final solution? So 2500 minus 3045. My calculator says 17455. 17455. So this is the answer of the sum of all terms that are not divisible by 7. Question, remember what the question said? Let me just bring it up so that I remind you. Here is what the question was saying. So much paper around here. Oh, here we go. This is what the question was saying. Consider the sequence. There it is. The question says determine the sum of all terms that are not divisible by 7. So we had to work out the total, the sum of all terms, and then we had to siphon, if you like, get the sequence of terms divided by 7, find the sum, and then we would subtract the sum of all terms divided by 7 from the sum of all terms. And then what we got was 17,455 as the sum of all terms not divisible by 7. Now, this is 5 marks. I'm going to leave it to you to try and see how you would distribute the 5 marks. It comes also this one most of the times. Sometimes it will be 5 marks, sometimes it will be 6 marks, but it cannot be more than 6 marks. Right, so if you are new to this channel, please subscribe and support us by inviting friends to subscribe. We value your comments. Give us feedback. It helps us when we're designing these videos to make sure that we cater for those concerns and suggestions that you guys give us. All right, like I promised, from this now, I'm gonna have to come back with another video to deal with these topics in detail, sequences and series. I'm gonna start with arithmetic sequences, linear sequences. When I'm done with that, I'm gonna go to geometric sequences. When I'm done with that, I'm gonna look at combination of the two, and then we look at the quadratic one. That will be the end of sequences and series. And then I'll tackle another topic concerning high school mathematics. But I'll be doing grade 12 mathematics, university first year and second year, and then I'll also be touching on statistics, physics, and so on. All right. We'll see you next time then.